This is a video about the probability actions. First, we're going to look at the one for equally likely. I'm going to go to the program and we're going to look at it. I highlighted the routine in green here. First, it does a reset to all probability distributions, so they will all start at the beginning. Then it sets SG to the value of 1. That's going to be used down here as the seed value for the probability distribution. Next, it fills 100 values at value with 0. Then it sets M to 100 and to 5,000. Then it says for J of 1, and down here it says next JN. Well, N is 5,000, one at a time. So it's going to go around here 5,000 times. Each time it's going to use the PEC action to get an equally likely outcome of M outcomes, which up here we said is 100. So this value of V is going to go from 0 to 99. That represents the 100 possible outcomes there could be. Then it saves a particular outcome here in a list called value. So at value plus V, that's which outcome it was, it adds 1 to show how many outcomes there were of V. Then it finishes this loop, and then it goes and draws the chart. So let's execute it again and see the chart. Here for equally likely, here is the chart. There are 100 possible outcomes. There's a bar here for each one of those outcomes. The height of the bar represents how many times that outcome was seen in the 5,000 times. Well, you notice they're not all the same height. That's because it's random. The PEC action was used, and it picks them randomly from, but equally likely, but still it's random. Now I've advanced the task to task 1, which is about normal distributions. It also uses the action of PEC. Well, I'm going to go to the program. I've highlighted in green here the routine for PEC as a normal distribution. Again, it resets all probability distributions, so we'll start at the beginning. Sets the seed to 1. Fills the 100 values with 0. Again, there's going to be 100 possible outcomes. Sets N to 8,000. That's how many times it's going to select an outcome. Next, though, because this one is not equally likely, this PEC is going to be for a normal distribution. So it sets this first value to 0. The next value will be the mean, and we're going to have a mean of 50. And then a standard deviation of 12. Well, down here, for J of 1, down to N, which we know is 8,000, it will go around this loop 8,000 times. Each time it's going to issue the PEC action again with the seed that it's given, which we know is 1. And then here are those 3 values in a row, the 0 indicating it's not equally likely because it's saying that there's 0 number of them. That can't be right, so then it knows it must be a normal distribution and knows that the next value it finds after the 0 value, this 50, will be for the mean, and the next value will be the standard deviation. So it's going to go around here 8,000 times and issue the PEC action. It's going to be a random value, this value of V, and we know it's going to be found out from this normal distribution, the value of V. But this value of V is going to vary from 0 to another value, but any value in between. It's not going to be an integer. This is from a normal distribution. so it's not integer. But the next instruction says round it. Round the value of v to make it integer, because we want to draw a graph showing it, and we're not going to have an infinite number of poles to measure it. So here we add to value plus v 1 to indicate how many times that outcome was seen. Here's the end of the loop, n times 8,000 times. We're going to ask it to pick another from a normal distribution, and we round it to make it an integer. Well, let's execute it again and go look at it. Here's our normal distribution. Because it is random, it's not a perfectly shaped bell curve, but you can see it bends in and then it bends out, and it bends in like a normal distribution should. But we can't prove all the way that this is a normal distribution, but we could do a test to make sure that it is likely to be a normal distribution, and you see it does appear that way. Now we use the seed of 1. We could use a seed of 2, and it's going to pick differently randomly and will look different, but still have the general shape of a bell. Alright, next we're going to go on now. Now we've moved on to the action pick. It needs a frequency distribution. Here we'll go to the program and take a look at what it did. Does the reset, sets the seed to 1, fills the 100 possible outcome counts to 0, and then it's going to build a frequency table. First, it sets the value at frequency to 100. Then it sets j to 101. Then it's going to go around this loop for I of 1 to the next I 50. But each time it goes around, it's going to define 2 different outcomes and put the frequency for 2 different outcomes in this list called frequency. And each time it goes around, it adds 1 to A and gets another one from the one end and subtracts 1 from J and moves in from the other end. Well, what we're going to do, instead of actually going and following this as it goes around, we're going to go over here and say we want to list the values in frequency. And here they are. First number said how many values there are in this table of frequencies. It says 100. Well, here it goes from this one down to this one, and there's 20 times 5, there's 100 different ones. This is the total of all these values, the sum of all frequencies. Then the first one as frequency of 1. That means it's expected to occur only 1 time in 2,550. And if we go to the last one, which is down here, it's also a 1. But as we progress, it becomes 2, 3, all the way up till it gets to 50. And the other one goes from 50 back down to 1, but it got built the opposite way. Remember, we subtracted 1 from J, and it went backwards until it got here to 50. So this is the frequency distribution. And here at 50, the probability of this is 50 divided by 2550. That will give its probability that this is the outcome. So notice, its possibility is 50 times that of the first one. Well, this is the probability distribution by frequencies. We'll end that. We'll go back over here. So it built the frequency table. Told us there was 100 values, and from that frequency distribution we could tell the likelihood of each one of the possible 100 outcomes. Next, it sets n to 5,000. Well, that's the number of observations it's going to make using the pick. It says for J1, And then down here, next J to N, 5,000, one at a time, it's going to do a pick using that frequency table, using the seed of 1. This value of V is going to go from 0 to 99. And down here, every time it has a particular observation, it's going to add it to that count for that outcome, 1. All right? Let's go back and see it. Now we know that at the beginning, the likelihood of this one here and this one at the other end was 1 in 2,550. We know that the probability of these in the center were 50 in 2,550. So notice they're more likely. But again, this is not a smooth line going up there and a smooth line coming down because they were picked randomly. Now we're going to choose from a frequency distribution without replacement. The action for that is puck. Let's go look at the program. Here is a program that has the puck action in it. It also changes things over time. So here it says if there's been 2,550 picks, don't pick anymore, go to EE, go down here, because there's no replacement and there's only 2,550 possibilities in the frequency table. You see, we're using the same frequency table that we used up here when we were doing pick action. But this time, they're not replaceable, so it can only do the observation one time. That is to say, the first one, remember, was one chance in 2,550, so it's only going to be picked once. We don't know when it's going to be picked, but it's going to be picked randomly. But once it is picked, it can't be picked again. The thing is, for those that said they could be 50 times in 2,550, well, then they're going to be done exactly 50 times and no more. So each one is going to be done by the number of its frequency. That's how many times it will be found. And here we see the loop for I of 1 to 25. It's going to just do 25 observations each time. So it's going to go around here many times. But each time it'll just do 25. And as before, it's going to add a value when it's found. This time it's adding a value of 4. That's just to make our vertical bars taller so we can see where they're at, and it forms a nice pattern for us. And every time it goes around, it changes the value of TG because it only wants to go to 2,550, because once it's there, it's found every observation and is done. Well, let's go back and look at it. We'll execute it. Now what am I going to do? I'm going to go around again so we can see it doing it. There, it's doing it. 25 at a time until it's done. When it gets to 2,550, it's done all of them. So notice this is a very nice straight line going up, straight line going down. This one got observed just one time. This one time. These two in the center each got observed 50 times. This is without replacement. That is the puck action. I like to say the U in puck stands for unreplaced. Alright, this is the end of the video on the probability actions.